Welcome to section 7.4, overloading methods. In this lesson, we'll learn how to write multiple versions of the same method or constructor using different parameters to handle different scenarios. It's a clean, powerful way to reduce redundancy and make your classes easier to use. Here's what we're going to cover: the idea of multiple constructors in a class, what method overloading means, what makes a method signature unique, and how to know when you can or can't overload something. In exercise 1, head over to puzzle 8 in the Java puzzle bomb game. As you play, take note of how the lights behave around the wheel. You'll start seeing where this is going and how overloading makes things smoother. So why did we even add lights to the wheels in the first place? Funny enough, it wasn't part of the original design. But players were getting confused. Some didn't realize the wheel would snap to the nearest 45-degree increment. To fix that, we added 8 lights per wheel, one at every snap point. The light that glows brighter, that's where the wheel will actually land. Now, players can visually predict the rotation behavior. Each light needs 3 things: which wheel it belongs to, what its rotation is, whether or not it's lit. Simple but important. So here is a class that models a light. To use it, UI wheel light, light 1, assign new UI wheel light, blue wheel, 45, false. But typing out that third false value 89% of time, not great. Here's why it's worth solving. 8 out of 9 lights are unlit by default. So in most cases, the third argument is the same. It's cluttering your code without giving you much value. Lights don't actually turn on and off. Instead, when a light should be on, we instantiate a 9th light and position it on top of the corresponding off light. That's where overloading constructors come in. We write another version of the constructor, one that doesn't take that third argument, but assumes false by default. So now our class has 2 constructors. Same name, different parameters. This is overloading. Now we can write UI wheel light, light 1, assign new UI wheel light, blue wheel, 45, or UI wheel light, light 2, assign new UI wheel light, blue wheel, 90, true. Java figures out which version to use based on the arguments we provide. In exercise 2, go back to your present test project. You've got a constructor with 2 arguments. Now create a no argument constructor that sets name to be null, height to be 0.0, sentence to be 0. Then instantiate a prisoner using that constructor. Try printing the values. Looking at both constructors side by side, we see a pattern. They do almost the same thing, just with different values. So let's clean it up. We're repeating a lot of code. Fortunately, constructors can actually call each other using this method. It keeps our logic centralized. This version reuses the logic from the 3-argument constructor. This is helpful because if the logic in a constructor needs to change, then the code needs to be changed only in one place. Depending on where you click, the yellow light behaves slightly differently. X and Y are the X position and Y position where the mouse was clicked. So let's zoom out. Any method can be overloaded, not just constructors. All versions must have the same method name, but a different signature, meaning number, type, or order of parameters. Let's say we've got a calculator class. You can write 3 overloaded methods as you see in the slide. Different number of parameters means valid overloading. Or how about different types? Still a valid overload. Java can tell the difference. And even parameter order matters. Same types, but different order, meaning different method signature. Now, when you call the method calc.sum1, 2, it goes to the int version. Calc.sum 1.5, 2.5, it goes to the double version. Calc.sum 1, 2, 3, it goes to the 3 int version. Java matches your code with the closest matching signature. In exercise 3, add 2 display methods to your prisoner class. One with no parameters, it prints all the fields. One with a boolean, it prints all fields and if true, also calls thing. Try coding both on the same object. Again, don't duplicate code unnecessarily. If one version does all the work, have the second version call it. Here's how. This is helpful because if the calculations are wrong or need to be adjusted, then the code needs to be changed only once. In exercise 4, take a look at both your constructor and display methods. Are you repeating code? If so, refactor using this method or internal method calls. The goal is clean, maintainable code. Let's zoom in on method signatures. A method signature includes a method name, number of parameters, type of parameters, order of parameters. As long as one of these changes, you can overload it. But the signature does not include the parameter names and the return type. Changing either of those doesn't count as overloading. So in this case, sum 1, 2, 3, it goes to the version with 3 parameters. Easy for Java to match based on the number of inputs. But what about this? This won't work. Even though the names are different, Java sees the same signature and throws an error. Same deal with return types, still a conflict. Return types don't matter in the signature for overloading. Overload first. Only after the method signatures differ can you change the return type or parameter names. To summarize method overloading, same method name, different number, different type, or different order of parameters. Optional, different behavior or logic inside each method. By now, you should be able to understand why multiple constructors can be helpful. Define and recognize method overloading. Explain what makes a method signature unique. And know what doesn't count when overloading.